If there's one thing folks usually agree on, it's that schools ought to be safe, attractive places for our kids to learn. Well-planned and maintained school grounds are a source of pride for students, teachers, parents, and the community. Unfortunately, Mother Nature doesn't always cooperate. Pest problems like insects, weeds, and plant diseases often stand between us and the perfect landscape. Dealing with pests can be an exciting challenge or an overwhelming task, depending on how you look at it. To complicate matters, you probably wear a lot of hats around your school. If you have found pest control to be complex in the past, the ideas in this video will help you gain control, so you'll have more time to devote to your other duties. Landscape pests don't have to be your worst enemy. If you've been following our series, you already know that Integrated Pest Management, or IPM, can help you get a handle on pest problems indoors. Well, the same strategy also works outdoors, in the school landscape. IPM, simply stated, is a common-sense, environmentally sound strategy for managing pests. Outside, IPM uses a variety of tactics to prevent pests from reaching damaging numbers in the landscape. I like to think of IPM as working smart, not hard. IPM is based on knowing the pest, how to identify it, when and how it does its damage, and when it's likely to be a real problem. IPM is also based on a thorough knowledge of the many tactics we can use to control pests. Our arsenal of IPM tactics can be thought of as a pyramid. The foundation of an IPM pyramid is based on different cultural practices that can reduce pests. These cultural controls include using plants that are resistant to pests, special planting and horticultural practices that limit pests, and proper plant maintenance. By using the right cultural techniques, we can maintain healthy, strong plants and eliminate many pest problems before they start. The next section of the IPM pyramid represents other non-chemical control methods, such as mechanical methods. Mechanical controls use manpower or materials other than pesticides to suppress pests. Mechanical controls include physically removing, trimming, or excluding pests from the landscape. This mulch and weed block fabric is an example of an effective mechanical control for weeds. Biological controls are next. Biological controls include the use of beneficial organisms to help control pests. One biological control might be using special microbes to help prevent disease organisms from invading plant wounds, or releasing insect predators to control insect pests. The top of the pyramid represents chemical controls. Although there are environmental risks associated with some pesticides, IPM doesn't rule out their use. IPM does require, however, that pesticides are chosen and used carefully. With IPM, we try to use the least hazardous product that can control the pest practically and economically. And we limit the use of pesticides to times when they are really needed. Notice that pesticides make up the smallest segment of the IPM pyramid. After all, you don't want to have to dress like this just to go to work. In a minute, we'll look at how the IPM pyramid applies to weeds, insects, and plant diseases. But first, well, I'll be right back. When it comes to building and maintaining a great landscape, planning is everything. After all, the pyramids weren't built in a day. By the same token, neither will a smoothly functioning IPM program. Landscape IPM starts with good landscape design. Unfortunately, many landscapes are not planned with potential pest problems in mind. When we plant plants that are known to be pest-prone or that are easily stressed out under local growing conditions, we increase the chance of pest problems later on. Planning is very important if you want to prevent pest problems. One effective planning technique is the management zone concept. This is a way of classifying landscape sites according to maintenance levels. Here's how it works. First, locate a map of your school grounds. Then, divide it into zones according to site visibility: high, medium, and low. Highly visible sites would be likely candidates for a high maintenance zone. Likewise, background or low visibility sites would fall into a low maintenance zone. Only low maintenance plants should be used in areas of low visibility. Higher maintenance plants should be kept to a minimum and planted in areas of high visibility, where your efforts will have the greatest impact, such as the main entrance to your school. Once you've zoned your landscape the way you want, gather information about the best plants for your area. A qualified nurseryman, landscape architect, or university extension representative can help you choose the best plants for your needs. Even a good bookstore or library can help. Don't make the mistake of assuming that a plant which does well and looks nice in a book or magazine will do well where you live. Plants are finicky. Don't be afraid to compare an architect's plant recommendations with a local plant expert before signing off on a landscape plan. A little research at the planning stage can go a long way toward reducing IPM costs later. Chances are you're starting with a less than perfect plan. In these cases, you need to plan for gradual, desired changes over time. But by taking the time to classify your school's maintenance zones, you're off to a good start. Now we're ready to talk about the first of those landscape challenges, weeds. Experts say there's really no such thing as a weed, at least scientifically. A weed is merely a plant where we don't want it. That is, a plant out of place. Even desirable plants, like this Bermuda grass, can become weeds if they invade plant beds. Weed species are grouped according to their life cycles: annuals, biennials, and perennials. Annuals, like crabgrass or annual ryegrass, begin each growing season as seeds and complete their life cycle in 1 year, usually producing a lot of seeds right before they die. Biennials need 2 years to complete their life cycle. Dandelion and milk thistle are 2 types of biennials. Plants that live for more than 2 years are classified as perennials. Perennial plants usually grow from sturdy underground roots, like tubers or rhizomes. Perennial plants that have developed a good root system can be very difficult to control, like this nutgrass. These nutlets can sprout back even after the top portion of the plant is killed with a herbicide or pulled up by hand. Preventing species like this from becoming established will be a major challenge for your weed management program. Another way to classify weeds is by the width of their leaves. Dicots with wide leaves, like this, are called broadleaves. Grasses make up the narrow-leaf plants. This classification will be useful later when we talk about chemical weed control. There are many weed control tactics, but when it comes to controlling weeds in turfgrass, the most important are cultural. For instance, selecting the proper turf grasses for the different sites at your school can make a big difference. A well-adapted grass, given the proper care and fertilization, makes weed control much simpler. Let's look at some examples of cultural control strategies. Mowing grasses at the right cutting height is important. Research has shown, for example, that proper mowing height and frequency can reduce crabgrass germination by as much as 85%. This is because a dense, healthy turf prevents light from reaching the weed seed, something it needs to germinate. Annual weeds, such as Poa annua and chickweed, thrive in areas with too much moisture. By establishing good soil drainage patterns and using proper irrigation, you can keep problems with these weeds to a minimum. This research plot dramatically shows the effect of irrigation, or lack of it, on weeds. This portion of the plot receives less irrigation than this other area. Notice how more weeds invade turf that receives too little water. Soil compaction can also affect the weediness of turf. Some weeds, like goosegrass or knotweed, thrive in soils that are compacted. This happens in areas with frequent vehicle or foot traffic, as often is the case in sports fields. Soil aerification can be of major benefit in such sites. By opening holes in the turf, aerification encourages growth of desired grasses and discourages weeds that favor compacted soils. The best times for aerification are spring and early summer for warm season grasses like St. Augustine and Bermuda grass. Cool season grasses like fescue and bluegrass are best aerified in the fall or early spring. Special equipment is usually needed to aerify compacted soils. These machines are readily available through most equipment rental stores. In addition to cultural controls, mechanical methods can also be effective. Mechanical barriers can keep weeds out of planted areas. Wood, plastic, or metal edging should extend 6 to 8 inches deep and 2 to 3 inches above the soil to keep creeping grasses out of plant beds. Sharp metal edging should be avoided on school grounds for safety reasons. Wide cement or brick barriers are even better. This type of edging allows mowing equipment to closely cut grass growing along the barrier edge and helps reduce time-consuming trimming activities. Weed removal by hand, cultivation, and mulching are also effective mechanical tactics, especially in high-maintenance shrub and flower bed areas. Mulching does two good things for plant beds. It provides a barrier to weeds and excludes sunlight so that annual weed seeds are discouraged from germinating. Also, in dry parts of the country, mulch helps retain soil moisture for your plants. Mulches should be at least 3 to 4 inches deep for maximum weed control. Weed barrier fabrics can enhance the weed control properties of mulch. Avoid the mistake of piling mulches up against the trunks of plants. This practice can provide an open door for some insect and disease problems. Unfortunately, there are few effective biological controls for common weed problems in managed landscapes. This may change in the near future. Until then, check with your local university or cooperative extension office to see whether biological controls might be practical for weed control in your school's landscape. Some weeds can be tolerated in turf grass, especially in low-maintenance zones. As long as these sites are planted with a well-adapted grass and mowed regularly, little additional attention is usually needed. In high-maintenance areas, such as sports fields or around high-profile administrative buildings or school entrances, additional weed control may sometimes be desired. In such sites, chemical weed control may be used. Herbicides are chemicals used for controlling weeds. Chemical weed control is one of the most effective and time-saving methods for weed control. Unfortunately, the safety of some herbicides has come into question in recent years. Although most weed killers are relatively low in toxicity to humans, it's a good idea to minimize their use around school grounds. When selecting herbicide products, look for materials with the lowest toxicity classification. These can be recognized by the caution signal word on the front panel of the product label. When herbicides are used, some schools use chemical dyes to alert students and staff to sprayed sites. This technique is especially effective in combination with posting. It's always a good safety practice to post or otherwise restrict access to sprayed areas until after the spray is dry. A common practice is to post treated areas for 24 hours after an application has been made. Oh, and avoid spraying herbicides on windy days, as this can result in drift, which can damage nearby plants. Most modern herbicides are selective. That is, they kill only certain types of plants. For example, this product is designed to control only broadleafed weeds like dandelions. This product controls only grasses, leaving broadleaf plants unaffected. It's important to understand, however, that herbicides don't necessarily distinguish between weeds and desirable plants. For this reason, pay close attention to the labels on herbicide products and follow them closely. Herbicide selection is a complex business, so it's best that employees who apply herbicides be thoroughly trained in their selection and use. Infectious plant disease is a plant problem caused by microscopic organisms known as plant pathogens. Plant pathogens are some of the most difficult to diagnose plant challenges. The most important disease-causing organisms include fungi, bacteria, viruses, and nematodes. Fungi-caused diseases include the powdery mildews, rusts, leaf spots, root rots, and wilts, including Dutch elm disease and oak wilt. Up close, some fungi are visible using a hand lens. Look for fine thread-like structures called hyphae. Also, look for small pimple-like structures called fruiting bodies. Spores from fruiting bodies are how fungal diseases spread. All ornamental plants are susceptible to fungal disease. Bacteria can also damage plants. Bacterial infection can cause shoot blight, leaf spots, soft rots, scabs, wilts, cankers, and galls. Bacteria do not have spores and are spread by splashing water, insects, or by moving infested plants, soil, or equipment. Nematodes are microscopic worms that feed on plants and other organisms. When plants look wilted and watering doesn't seem to help, or if when they show signs of nutrient deficiency, that's not corrected by applying fertilizer, suspect nematodes. Nematodes mostly live in soil. Galls or root rots are other symptoms of nematode attack. Nematodes are most often spread by moving soil from one place to another. They can even be transported on equipment or the shoes of workers. Viruses are the smallest of the common plant pathogens. Virus infection leads to stunted, discolored, or deformed plants. Viruses are commonly spread by insects like aphids or leafhoppers. Viruses can also be spread from plant to plant by root contact or via pruning equipment. Plant disease occurs when three things come together: a susceptible plant, the plant pathogen, and the proper environment. The key to successful control of plant diseases is to try and limit or eliminate any one of the three corners of the triangle. For example, many fungi need lots of water in the form of wet plants to penetrate leaf tissue. By watering plants only when leaves are likely to dry quickly, such as early morning, you make the environment less favorable for these pathogens. This person is removing the dead leaves, which contain spores that can reinfest leaves next year. Removing inoculum that may be hiding in plant debris is an excellent cultural control tactic. Consider using plants that are known to be resistant to plant disease. This crepe myrtle variety has been selected for its resistance to powdery mildew, a disfiguring plant disease. Plant diseases can be difficult to diagnose and cure. Symptoms for every disease vary, and there can be multiple contributing factors. It makes sense to talk to an expert.
It's very important to know what the causal agent of a disease is, because that's how you're going to decide what your management strategies are. The management strategies for fungal diseases are very different than the management strategies for bacterial diseases or viral diseases or nematode diseases. Send pictures, videotape snapshots, anything you can. Write as much of a description as you can about the symptom, when you saw it, what's been done in the past, what does it look like, how is it distributed. Any of those information will be helpful to the people in the lab as well.
Let's not forget about insects and mites. These critters are some of the most challenging pests for landscape maintenance. Probably the biggest challenge for the beginner in this business is learning to recognize insect damage. There are an estimated 10,000 different kinds of insect pests. So even after you determine that insects are the problem, it still may require some research to identify the suspect. Fortunately, there are many excellent books and guides to insect pests. Your local nursery, extension office, or plant consultant can also help. But be sure you know what it is that's bugging your plants before you reach for the sprayer. Insect damage comes in many forms. Leaf feeding can be caused by moth, fly, and beetle larvae, grasshoppers, and other insects with chewing mouthparts. Some of these pests chew holes in leaves. Others roll leaves up to feed. Others tunnel in leaves and stems. Sap-feeding insects can weaken or discolor plants or cause them to wilt. Common sap feeders include aphids, scale insects, lacebugs, whiteflies, and others. These insects often produce sticky sap that makes plants look unsightly and can hurt the plant's ability to produce food. Mites feed on the green contents of leaves. They are usually found on the underside of leaves. Damage can be recognized by a fine pattern of yellow or white spots on the top of the leaf. A hand lens is useful when looking for mites and other small insects like whiteflies. Borers are serious pests for trees. These insects are usually noticed because of the holes they leave in bark. Sometimes chewed and partly digested wood, called frass, is seen around exit holes and along trunks and stems. Some borers cause twigs to drop off of trees after a windy day. Damage due to insects and plant pathogens is sometimes difficult to distinguish from damage caused by environmental problems, like excessive heat or cold. In general, when insects are the culprits, you will either see them or characteristic signs of their presence, like fecal material, shed skins, or honeydew. Damage caused by either insects or plant pathogens is usually patchy and is irregularly distributed over one or several plants. Cultural problems like too much or too little water or under or over fertilization are more difficult to diagnose. If an entire plant is affected uniformly by the damage, or if different kinds of unrelated plants show the same kind of damage, cultural or environmental problems may be the reason. Now let's look at IPM tactics for insects and plant disease. Just as healthy turf grass discourages weeds, healthy plants are less susceptible to insect and disease damage. Good horticultural practices are the most important cultural controls for both insects and plant disease. Plants grown in soil that is continually kept too wet, too dry, or gets compacted are far more susceptible to disease problems than are plants receiving the right amount of water. In general, you can reduce plant disease problems dramatically by applying the right amount of water and placing it where it is needed most, at the root zone of the plant. Insects and many diseases are virtually drawn to woody plants under stress. For example, trees whose roots are damaged by construction or soil compaction are more likely to suffer from wood-boring beetles. Here are some examples of cultural controls that you can do to control pests. Check all newly purchased plants for insects and disease problems. Never accept infested plants unless you are sure you can control the pest effectively. The best control for most pests is to avoid getting them. Practice proper planting techniques when installing trees and shrubs. Place the root ball on solid ground in a hole so that the root crown is level with or slightly higher than the surrounding soil. If compost is to be added, mix it with a fill soil. Keep the soil around the new plant moist but not soggy. By mulching properly, and preventing weeds and turf from growing near the base of the new tree, you can promote rapid growth and development. Remove twine, plastic, or wire wrapping from new plants, as this can cause permanent damage and open the door to pest attack. And take steps to avoid mechanical damage to plants, such as mower damage to trees. Such damage can create an open door for pests like wood-boring insects and wood rot. Choose plants whose mature heights match your site requirements. Plants that require severe pruning to be kept to an acceptable height will be more pest-prone. Visit local nurseries, arboreta, or botanical gardens to see what plants do well in your area. Ask around about how big a plant is likely to get before you plant. Plant pest-resistant plants whenever possible. Information about well-adapted, pest-resistant plants usually is available through your state's Cooperative Extension Service. Mechanical control methods are also effective for controlling insects and disease. Bagworms can be controlled on smaller trees and shrubs simply by removing them by hand during the winter. In the winter, bagworm bags contain eggs that will hatch in the spring. Pruning is a form of mechanical control that can help or hurt plants depending on how it's done. Prune plants properly when young to avoid the need to prune larger limbs later. It's generally best to prune during the cool season when pests are less active. Prune and destroy declining limbs to eliminate pest breeding and spread. Sterilize pruning equipment before pruning your next plant with a disinfecting solution to avoid spreading pathogens. Oh, and by the way, tree topping is a drastic form of pruning that should always be avoided. This kind of pruning results in weak branches and trees that are much more susceptible to pest attack. Biological control is a tactic that is receiving a lot of attention lately. For insects, the most important biological control tactic is to conserve natural enemies whenever possible. You do this when you limit your use of pesticides and try and use products that have the least impact on beneficial insects. Insecticidal soaps and horticultural oil sprays, for example, leave no harmful residues to kill beneficial insects. When your plants are doing well, it's important to remember that having a few pests around is okay. Having a few pests does little damage and provides food for natural predators and parasites. This helps provide ecological stability and increases the chance that pests will remain at low numbers. Introducing beneficial insects to control pests may be helpful in a few cases, but you need to know exactly which pest you're after and understand the requirements and limitations of biological control. It's best to check with a qualified entomologist familiar with biological control in your area before investing significant money in purchasing beneficial insects for release. One type of biological control that is finding new uses every year is beneficial nematodes. These microscopic worms attack a variety of soil-infesting insects like root weevils and white grubs. They can be applied much like a regular pesticide, yet are very safe to use. Even plant pathogens have natural enemies. Some microorganisms prevent or suppress plant disease on a microscopic scale. For example, this product is based on a pathogen called gliocladium that helps suppress microorganisms that cause damping off and root rot diseases, common problems in bedding plants. Many similar products are now becoming available to IPM specialists. Insecticides and fungicides, forms of chemical control, are used to kill or repel pests. They can quickly suppress pest problems, but it's almost always temporary. Understand the limitations of pesticides and use them carefully, and follow all the label instructions. Overuse of pesticides can be harmful and disrupt the natural balance between pests and their enemies. Pesticides that pose little risk to humans or the environment are called low impact. Some of these products are natural or organic, but not all natural products are naturally safe. And some synthetic or man-made insecticides are actually very safe when used properly. Examples of low-impact insecticides include contact pesticides like soaps and horticultural oils, insect growth regulators, botanicals or naturally derived pesticides, microbial pesticides, and baits. Many of these products have little effect on beneficial insects like bees or predatory insects, but they can work very well in controlling pests. Remember that when following IPM guidelines, we always choose the least toxic pesticide that will do the job. With all these choices available today, it's not that difficult to find a low-impact pesticide to tackle almost any job. Any landscape IPM program will, by necessity, have to be tailored to your own region. Plants that do well in Florida may not be of much use in Washington State, and vice versa. Pests are different from one area to the next. But if you follow the guidelines we've outlined today, you can go a long way toward meeting those landscape challenges head-on. We all deserve a clean, safe, wholesome place to work and learn. And with IPM, it's just a little prep time away. A well-planned school environment is everything, and well-thought-out actions make for more effective solutions. No matter how many hats you wear around your school, the most important one is that of IPM professional. Integrated pest management in your landscape environment will make your school a place you and your community can take pride in, today and well into the future. Happy growing!